looks like I've got some people on here. Sorry for the glitchy sound. I am sharing my screen. There's some people here. So we're going to go ahead and get started. Again, I'm sorry. I wish it was better. And this is the bummer about it. With TeamViewer, I could totally see my screen. With TeamViewer, I could like have chat off to the side, but this I have to like make it kind of work weird. So you guys are going to kind of see the chat and it's going to be weird, but we're just going to go with it for today and find something better later. Okay, so let's go ahead and get started so we don't spend the whole day talking about our technology. So let's talk about angles. Okay, so up to this point in geometry, we have talked about, let me make this a little smaller. Up to this point, we've talked about a lot of different things with lines, right? We talked about, that's what I want up there. So can you guys all see this angles thing? Yes. You can see it. Okay, cool. And I think I can see the chat. Okay, good. I can see the chat. You guys can see that. It's not very pretty, but it's going to work for today. Okay, so up to this point, we've talked about lines, line segments, rays. We've talked about, you know, planes, all kinds of good stuff. Now we're going to get into angles. So I know you guys have done angles probably before in pre-algebra or in your math, but we are going to talk about what an angle is. So let's do that. So an angle is basically where two rays have the same endpoint. Okay, so that's the technical definition of what an angle is. But if you remember, a ray is a line with the endpoint that goes off on the other side forever. So we have two rays here, right? That's not what I meant to do. But basically we have our two rays and they connect at the same endpoint and they form an angle. All right, so we call this an angle. And an angle, when you write an angle, so if this is point A, we would call this angle A. So you get to make little baby angles all over your geometry homework. Okay. There's a couple of pieces of terminology that I want to make you aware of. So this is an angle. The side of an angle would be these two sides right here. So these are the sides of the angle. And then the point at which they meet here, this point A, is called our vertex. So this is the vertex of an angle. And the vertex is simply where those two endpoints meet up. You'll also hear vertex, like if you're talking about a shape, that's kind of, the vertex is like basically like a corner, you know, the word corner, like the corner of your square. It's like that word for angles. Okay. You've seen angles before, right? So let's talk about naming angles. Okay. So in this little picture right here, there's actually a whole lot of angles that we can name out of here. So we could name this angle here. Okay, we could call that, and I don't have a whole lot of room right there, so I'm gonna take my lines here and write them over here so I have some more space because I need a bigger space to write. Okay, so this red angle that I highlighted, I could call that angle JLK, or I could call that angle KLJ. I could not, well, I should say, what you want to notice is that for both of them, the vertex L, where they meet up, is in the middle. So you can't call this angle KJL, because that would be a different angle that we're talking about. So when you're naming an angle, if you're using, you know, different points, then the vertex is actually going to be labeled in the center of their angle. That was a bunch of words, but did that make sense? So if I want to label switch colors here. If I want to label this angle in green, right? I could call that KLM, angle KLM, or I could call that angle MLK. And again, the vertex is in the center. Okay, and then there is actually one more angle in here, which we don't actually think of as an angle, but the angle of the straight line here, right? That's 180 degrees. So we could call that angle JLM or angle MLJ. Fun stuff, right? Yay. All right, so has anybody done this before? Not too bad. It's pretty easy. Easy. All right, we'll take easy, right? Let's talk about classifying angles. I know most of you have done this before. We're going to talk about types of angles. So that's not what I wanted. Oh, man. Sure, we'll do that. You'll have a big red box there. I don't even know. Okay, so let's talk about these angles down here. What does classifying angles mean? So do you remember acute, obtuse, right, and straight? Do you remember those words? So an acute triangle, right? That's an acute triangle is one as a acute angle. Sorry, I'm thinking about triangles. An acute angle is any angle that is less than 90 degrees. So my kids remember acute by like, it's a cute little triangle, right? Basically, if this is angle A, the definition is that the measure, so you say the measure of angle A is bigger than 0 degrees, but it's less than 90 degrees. Okay, so we would read this as the measure of angle A is greater than 0 degrees and less than 90 degrees. And that would be acute. Okay. And then our next angle that we have below that is, and it's actually not labeled, but you can probably tell what it is. This is our right angle. And right angles are really important in geometry. So you're going to see them all the time. So we'll call this B, angle B. And a right triangle in geometry is indicated by a little square in the corner. Okay, so a right angle means that the measure is always 90 degrees. 90 degrees. Sorry, I'm drawing on my screen, so it doesn't always come out very pretty. Right angles are extremely important in geometry. In fact, we'll do a whole chapter just with things you can do with right angles. And yeah, so right angles 90 degrees, right? Then we have, up in the top right, we have our straight angle. Looks just like a line, doesn't it? So our straight angle, let's put a point on there, C. So this is straight. Okay, a straight angle means that the measure of angle C, oops, I forgot my angle sign. Measure of angle C is 180 degrees. So that's kind of what we were talking about up here with the purple one, right? Straight. And then our last one is obtuse. Okay, it's getting sloppier as I write. So we'll call this one D. And the measure of angle D is greater than 90 degrees. It's also less than 180 degrees. Exciting stuff, right? All right, you guys still with me? So let's do some more. You're still with me? Good. All right, so let's do some more with this. There's a couple more terms that I wanted to teach you. And then the actual work for it is actually, it's actually pretty easy, but we want to make sure that we know. All right, so let's talk about what the definition of a congruent angle. So if you remember last section, we talked about congruent lines, and congruent lines just basically mean that they're equal to each other, right? So what do you think congruent angles mean? Oh, that's a good guess. They have the same something, but it's not the length. So with angles, we're actually not worried, but we're worried about the measure of the angle. Okay, so two congruent angles actually have the same measurement. So let's draw a little picture over here. Okay, so a congruent angle would be, for example, if I have this angle and this angle, I'll try to draw them the same. Okay, and this is A and this is B, angle A and angle B. We would say that the measure of angle A equals the measure of angle B. Okay, so that would say that these two angles have the same measurement. So let's say that's 30 degrees. They're both 30-degree angles, right? So the angle A is 30 degrees, angle B is 30 degrees, and they equal each other. So that's talking about the measurement. So congruent, remember, is another fancy word that we use in geometry. So we could say that they have the same measurement. We can also say that they're congruent. So when you get to this word congruent, we would actually say that angle A is congruent to angle B. So remember how we talked about that congruent symbol and what that meant? That also applies to angles as well as lines for congruency. So there's a little bit of a weird terminology there I just want you to recognize. When you talk about the measure, that's that M in this stands for measure. And when you're talking about the actual measurement, you use the equal sign. And when you're talking about congruency, we don't actually talk about the measurement. We say that angle A is congruent to angle B. It's kind of a little weird terminology there. Oh, I just lost my chat thing. Sorry. No, I don't want to leave. Oh, yes. Whoever said this is so exciting. I'm glad that you're excited by this awesome geometry. Okay, another terminology, angle bisector. All right, so we talked about a bisector of a line, right? That was last section. So when a line gets bisect, that means it's basically getting cut in half into two equal congruent parts, right? So what do you think happens when an angle is being bisected? So the definition is an angle bisector is a ray that divides an angle into two angles, not angels, into two angles that are congruent. Instead of you letting me write that all out. There we go. A ray that divides an angle into two angles that are congruent. So if I have a angle, nope, that's not what I wanted to do. If I have an angle hanging out here, this is my awesome orange angle here. Okay, that's my angle. If I wanted to do an angle bisector, my angle bisector is going to be a ray that divides my original angle into two congruent parts. And remember, congruent means equal. So that means that this angle would be congruent to this angle. Okay, so here's a quick example of how we could use the congruency in the words angle bisector. And this is kind of why you have to pay attention to these words. Like the concepts are easy, but the words are what you really want to make sure that you're kind of tucking away in your brain for later. Okay, so what do I mean by that? It says ray EG, so ray EG for both of these, is the angle bisector of DEF. Find the two angle measures not given in the diagram. Okay, so see this picture here? We've got DEF and EG is the angle bisector. So they want us to be able to look at this and say, okay, angle GEF, right, is 52 degrees right here. So what other angles can I figure out the measurement of? Well, I can figure out what DEG is because we know that EG is the bisector. And by definition, this basically divides the angle in half. So what does that tell us that this angle is? DEG is. So angle D, I see somebody typing DEG. Yes, so somebody says congruent with GEF. That's correct. DEG is congruent, if I make my squiggly, with GEF. Come on, Ben, you can work today. All right. And that also means that the measure of angle DEG, I can't get my pen to work, DEG equals the measure of angle GEF. So basically, this is also 52 degrees. That makes sense? I mean, it's easy stuff. It's just understanding the terminology behind it. And that's supposed to be a 52. That's a crazy looking 52. All right, what other angle can we find? We can also find what is the measure of angle DEF. So DEF is this larger angle here. So we know that one angle is 52, the other angle is 52. So if we add them together, it will be 104 degrees. Okay. Easy stuff. Still so exciting. Easy. We like that. So there's just a lot to get through in this section, so we're just going to keep on trucking through so I can get you guys out of here, okay? We are going to talk about our third and fourth postulate, and they are going to look really similar to our first two postulates. So remember, postulate is just a rule that is accepted across geometry. Just there's no proof, but we just all accept them to be true. So if you remember, the first postulate that we learned was about how to measure a line. It said that we can measure a line by taking the absolute value between the 2 points, okay? For postulate 3, we're going to talk about measuring angles. And the tool that we use to physically measure a line is a ruler. And the tool that we use to physically measure an angle is a protractor. All right. So has everybody seen a protractor before, worked with a protractor? Okay. So you guys have all seen that. Okay. So that's good. So this tells us postulate 3, the protractor postulate. Consider a point A on one side of ray OB. Okay, the ray, or line, it should be line OB. The rays of the form OA can be matched 1 to 1 with the real numbers from 0 to 180 degrees. Okay, the measure of OAB, so this should say the measure of angle OAB, AOB, I'm saying it wrong, AOB, is equal to, let me just fill this in, the absolute value of the difference. It's all over the place today. Here we go. Between the real numbers for ray OA and ray OB. Okay, so basically once you fill this all in, this postulate is saying that we measure angles just like we measure lines, right? The measure of angle OAB is the difference between where the measure of angle A is and the measure of angle B. All right, so if we look at, it has to be between 0 and 180 degrees if we're using a protractor, which makes sense because the protractor has 180 degrees, right? So for this particular example, ray OA appears to be measuring at about, so I start here at 0. You can see my angle measurement. This is 90 degrees. There's 100 degrees, 110, looks to be about 115 degrees. Okay. Degrees, if I can draw that. And ray OB is measuring at 0. So the difference between 115 degrees and 0 degrees is 115 degrees. So we would say that the measure of angle AOB is 115 degrees. So we're just defining that rule. So now if you ever have to measure an angle, you don't have to say, the reason I can measure an angle is blah, blah, blah. You would just say that I can measure this angle because of the protractor postulate. Okay, and then postulate 4, if you'll remember, postulate 2 was that if we have a line, if you've done your homework, okay, postulate 2 was if we have a line and this is A, B, and C, okay, if A to B is 5 and B to C is 8, then we can add them together and A to C is 13. All right. So guess what? Postulate 4 has to do with angles, and it's the same thing. It looks like a lot of words, and it is a lot of words, but it's basically the same thing. So if P is in the interior of angle RST, so there's this angle out here, RST, okay? Try to copy it, this angle, okay? And there is a ray that's dividing it. Oh, that's bad. This angle, this ray P is dividing it right here, okay? If you add this angle plus this angle together, you're going to get the total angle. So the fill-in would be, if you have angle RSP plus angle, so that's RSP plus angle PST, and you add two angles together, guess what? You get the whole angle. You get angle RST. So now, whenever you're doing your homework, we have postulate 4. If you need to add two angles together that are part of a larger angle, you're allowed to do that based off of postulate 4. So this is the fill-in for that. That makes sense. Just basically kind of, we're setting all the groundwork so that when you get there, you'll be good to go. Any questions? All right, I think we're done with all the rules. So now let's just do a couple examples from this section and we will be good for the day. So the first one is classifying angles. Okay, so measure the angle, then classify the angle as acute, right, obtuse, or straight. So I don't have an online protractor that we can use. I do have a bunch of protractors that I can bring to class. So if you don't have one at home, I will bring that in. But let's just look at these and see based off of how they look if we can figure out, are they acute, right, obtuse, or straight? So the first angle, letter A. I know, I'm glad you guys are having fun. Hey, it's better than it being really hard, right? So first we have angle AFD. So let's label that on here. AFD. AFD. So what does angle AFD look like? Do you think that is a acute, right, obtuse, or straight angle? Obtuse. I think that was Greta. I think Greta was purple. Is that right, Greta? All right, Greta got it. Angle AFD is obtuse. So there we go. There's our obtuse angle. And if we measure it with a protractor, I got about 135 degrees. So this is like that. But if you don't have that, it's okay. All right. What about angle AFE? So we have AFE. I just saw somebody blow up something on the screen. AFE. What do you think? Does that look, that's the orange one. Obtuse, right? Acute. Yes. I see a couple of acutes on there. That's going to be an acute angle. It's less than 90 degrees. Nice job. Okay. What about BFD? BFD, we're going to be doing blue. BFD. You guys are like on it. Yes, that is a straight angle. All right. And then what do you think BFC is going to be? BFC. Yeah, BFC is right here. It is our right angle. That's really all you have to do for that. Pretty easy peasy, right? Let's do some more examples. We're just going to go through 1-4 today, so easy peasy. I like it. But it's, so this is all, this is all, it should seem easy, but a lot of it is just getting that terminology down. Like, okay, what is an angle? If they ask me to find the angle bisector, what does that mean? And how do I do that? And all that fun stuff. All right, so there's no directions on here. But what they want you to do in number 3 is find the measure of angle ABC. So what do you think the measure of angle ABC is? Okay, so by postulate 4, right? Postulate 4 tells us that if we know that the angle of ABD is 50 and the angle of DBC is 80, we can add the two together, 50 plus 80, and we can, oh, I heard, yes, the measure, what's that? 130, right? No, I just wrote 180, 130. 130 by adding them together. Okay, what about the measure of HLK? So HLK. So this one's a little different, right? They tell us the total measure is 90, and they tell us that one of the angles is 30. So we actually need to do subtraction, but I see in the chat that we know that this is 60 degrees. And we are allowed to do, nice in the chat, we are allowed to do 3 and 4 without any explanation because of postulate 4. So if you say, why can I do number 3 and number 4? It's because of postulate 4. Okay. Let's try a few. I think there's just a few more examples, and we'll send you on your way. I know. You're welcome. Let's do 5 and 6, and then we'll come back to 9. Okay. Nope, that's not what I wanted to do. Throw some some algebra in there. How about that? Stretch our brains a little bit. Okay, checkpoint. Ray BD, that was a weird sound. Ray BD is the angle bisector of ABC. So what does that mean when we see angle bisector? What should that ring in our head? Angle bisector means that the two angles that are formed are equal to each other, right? Yes, they're congruent. So we need to figure out what the measure of those two angles are. So how are we going to do that? So by definition, I know that angle ABD is congruent to angle DBC. Oh, yes. Okay. Or the measure of angle ABD equals the measure of angle DBC. So what is the measure of ABD? Oh, they give us some algebra. They tell us the measure of ABD is 3x degrees. And what is the measure of DBC? That is x plus 20. So this is not too hard of algebra. We should be able to figure this out, right? We need to solve for x. So we're going to subtract x from both sides, and we end up with 2x equals 20. And if we divide both sides by 2, we end up with x equals 10. So then the question is, what is the measure of each of these angles? Well, ABD is 3 times 10, so this is 30 degrees. Nice, Greta. And DBC is 10 plus 20, which is also 30 degrees. And it is a good thing that they both worked out to be 30 degrees because this is the angle bisector. This is the angle bisector. So that means that these two angles have to be congruent and equal to each other. Okay. Do you want to do example 6, or you think you got that? Let's do it. We're here. Do 6. All right. I like to hear it. So let's see number 6. All right. Same. They use the same letters, so they don't have to write the directions twice. BD is the angle bisector of ABC. So that means that this angle is congruent to this angle, which also means that the measures are equal to each other. So you don't have to watch me write this. All this still holds true. Same terminology still holds true. So what that means practically for this is that measure of angle ABD is 6x plus 15. Okay. The measure of angle DBC is 10x minus 25. So let's do some algebra. So we want to get the x's together, so we're going to subtract 6x from both sides. So we're left with 15 equals 4x minus 25. We're going to add 25 to both sides. And we're 15 plus 25 is 40 equals 4x. And somehow again, when we divide both sides by 4, we get equals 10. Okay, so when you get x equals 10, you might be tempted to say, oh, I'm done. But now we have to plug that back in to figure out what the angles are. So the first one is 10 times 10. I'm doing this one. 10 times 10 minus 25. So 10 times 10 is 100 minus 25 is 75 degrees, right? The measure of DBC, we would technically say the measure of DBC is 75 degrees. Then what about the measure of ABD? The measure of ABD better be 75 degrees too, right? So if I plug in 10, 6 times 10 is 60, plus 15 is 75 degrees. Yay, it all works out. This is easy. All right, that's a good thing. I don't think you have any homework on problem 9. We might just warm up with that on Monday. Or if you get to your homework and you have one like that, let me know. But most likely, just to give you guys a heads up, we will finish up 1-5 and 1-7 on Monday. So just make sure you're keeping up with your homework and you should be good. You guys are all good anyway, right? So that's it for today. Technology kind of worked, right? We'll kind of see. I don't know if anybody was trying to talk and they didn't get a chance to talk, but we'll figure something out quickly here. So thanks for being flexible.